Let's solve problems on Bayes' theorem now. Look at the first one. A bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the two bags is selected at random and a ball is drawn from the bag, which is found to be red. Find the probability that the ball is drawn from the first bag. Okay. So first we'll define the events. Alright, let's say we have E1 to be selecting from the first bag, and say E2 is selecting from second bag, and we have to define the event A, correct? So event A, let it be selecting a red ball. Now what is there, what is not there, we'll try to figure it out. Now P of E1 is going to be, see, there are 4 red and there are 4 black. Probability of choosing the red is going to be just half, correct? So P of E1 is half. Now P of E2, you can say that this is 2 out of red, but then remember, E1 is what? Selecting from the first bag, E2 is selecting from the second bag, right? Since there are only 2, P of E1 is equal to P of E2 is equal to 2. Alright. Now we are not looking at the red and the black balls, we are looking at the event of choosing from that particular bag. Fair enough? Now A is what? Selecting a red ball. Okay. Now what we'll do? We'll look at P of A given E1 and P of A given E2. You have P of A given E1. P of A given E1 is how much? 4 divided by 8, which is half. And P of A given E2 is going to be 2 out of 8, which is 1 by 4. Make sense? Now, what is the final formula? Like using the Bayes theorem, what will be the final formula? So we have to take the formula P of E1 given A, correct? Because find the probability that the ball is drawn from the first bag, and that too it is found to be red and it has to be from the first bag, correct? So you are going to have P of E1 into P of A given E1 divided by sigma, same thing, P of EI into P of A given EI, correct? So we have P of E1 half into A given E1 is half divided by half into half plus half into 1 by 4. Make sense? So 1 by 4 plus 1 by 8. Alright? So if you take LCM and if you solve it, you will get 2 divided by 3. So answer for the first one, that is P of E1 given A, is going to be 2 by 3. So this is the answer for the first one. Alright, now let's do the second problem. Look at the second question. In answering a question on a MCQ, multiple choice test, a student either knows the answer or guesses. 2 events are there: knowing the answer, guessing the answer. Let 3 by 4 be the probability that he knows the answer and 1/4 that he is guessing. Assuming that the student who guesses at the answer will be correct with probability 1 by 4, what is the probability that the student knows the answer given that he answered it correctly? Okay, now let's write down what is given. So we'll take E1 to be the first event. So first event is going to be that the student knows the answer. So E1 is knowing the answer. E2 is going to be guessing the answer. Okay, guessing the answer. And we also have to define A, correct? Event A. So event A is what? The answer being correct. So either he knows the answer or he guesses the answer, in both the cases, what we require or what is there is, see, assuming that the student who guesses at the answer will be correct. It is correct. So P of A is answer being correct. Answer being correct. Fair enough. Now let's see what is P of E1, P of E2, A given even, all those things. So first, P of E1 is 3 by 4. Look at the first part here. It's right here. 3 by 4 is the probability that he knows the answer. Correct? So P of E1 is 3 by 4. P of E2 is 1 by 4. Isn't it? Now see the next one. Assuming that the student who guesses at the answer will be correct with probability 1 by 4. Right? See, P of A given E2. This is going to be 1 by 4. Now we need P of A given E1, right? Say P of A given E1 is going to be 1 because the student knows the answer and student is getting the correct answer. That means the probability has to be 1. Think about it. You know the answer and you are going to answer it correctly. So probability will be 1, right? So this is P of A given E1, A given E2. Now the formula is going to be same, P of E1 given A in this case. What are they asking here? See, they're asking you to figure out P of E1 given A. So P of E1 given A is equal to, the numerator is going to be P of E1, it's 3 by 4 into P of E1 given A. So A given E1, which is 1, divided by 3 by 4 into 1 plus 1 by 4 into 1 by 4. So 3 by 4 plus 1 by 16, correct? Which is going to become 12 by 13. So the final answer is P of E1 given A is equal to 12 by 13. So this is the answer. That is the probability that the student knows the answer and he has answered it correctly. That probability is 12 by 13. And if you look at it, guys, it's a very high probability, right? That's why this is the answer. Fair enough? Now let's do the third one. See the third question. There are 3 coins, right? One is a two-headed coin, head on both the faces. Another is a biased coin that comes up head 75% of the time. Third is an unbiased coin. One of the 3 coins is chosen at random and tossed. Alright, it chose heads. What is the probability that it was the two-headed coin? Okay, quite a simple one, very direct actually speaking. See, we'll take 3 events, we'll define E1, E2, E3. 3 events. The first event is selecting the two-headed coin. Selecting two-headed coin, this is going to be E1. Next, E2 is selecting a biased coin. So this is selecting the biased coin. Third one, selecting unbiased coin. Selecting the unbiased coin. Now what is event A now? So event A is getting ahead, isn't it? So event A is getting ahead when you toss. Getting ahead when tossed. Alright, now let's look into this. Very, very simple. Now P of E1, P of E2, P of E3, this is going to be 1 by 3, isn't it? So we can say that P of E1 is equal to P of E2 is equal to P of E3, and all 3 of them, they give the same probability, that's 1 by 3, right? Now P of A given E1, So it's getting a head, selecting a two-headed coin. Obviously, it's going to be 1 because both the sides are head. There is a 100% chance that you will get it. You will get head, isn't it? Next, P of A given E2. There is a 75% chance that you will get a head. That's 3 by 4. And P of A given E3, 50%, which is half. Unbiased, right? 50%. Now, what is the question? Find the probability that it was the two-headed coin, right? So, two-headed coin, again, we have P of E1 given A. So, P of E1, which is 1 by 3 into 1 divided by 1 by 3 into 1 plus 1 by 3 into 3 by 4, correct? P of A given E2 plus 1 by 3 into 1 by 2. Make sense? So this will be 1 by 3 plus 1 by 4 plus 1 by 6. 3, 4 and 6, the LCM is going to be 12, isn't it? So when you solve this, you will get the answer as 4 by 9. 4 by 9. So P of E1 given A is going to be 4 divided by 9. Fair enough? So this is going to be the answer for the third question. Let's do the next one. Look at the fourth one. An insurance company insured 2,000 scooter drivers, 4,000 car drivers, 6,000 truck drivers. The probability of an accident are 0.01, 0.03, 0.15 respectively. Or one of the insured persons meets with an accident. What is the probability that he is a scooter driver? Okay, now we have 3 events. First is a scooter driver, second is a car driver, third one is a truck driver, correct? So what we'll do, we'll take E1, let E1 be the driver is a scooter driver. So this guy is a scooter driver. E2 is going to be a car driver. And E3 is going to be a truck driver. Fair enough? Now what is A? A is that, look at the question, one of the insured persons meets with an accident. The person is getting into an accident. So A is that person is meeting with an accident. Fair enough? Okay, now let's do the probability. Let's do the math. Now, see, the question says the probability of the accidents are this much, right? Now, what is the probability that you are choosing a scooter driver? Look at the question. The company insured 2,000, 4,000, 6,000 people. Like in total, don't you think you have 12,000 people? Correct? 2,000 plus 4,000 plus 6,000. So in total you have 12,000 people, of which 2,000 are scooter drivers. So we can easily say that probability of E1 is going to be 2,000 by 12,000. That's 1 by 6. I hope this all of you have understood. P of E2 is 4 by 12. That's 1 by 3. Then P of E3 is going to be 1 divided by 2 because 6,000 out of 12,000. Now P of A given E1, that's given to you, right? P of A given E1, that is the person meets with an accident and that is a scooter driver, right? So if that is the case, that's 0.01. Then P of A given E2 will be 0.03. P of A given E3 is 0.15. Correct? Now the question says what? That probability that he is a scooter driver. So we need P of E1 given A. Right? So P of E1, 1 by 6 into 0.01 divided by 1 by 6 into 0.01 plus 1 by 3 into 0.03 plus 1 by 2 into 0.15. Correct? This is the total, whatever the Bayes theorem, if you apply, this is what you will. So if you solve this one, you will get 1 by 52 as the answer. So the probability is 1 by 52. Very less chance, but still there is a probability of 1 by 52. Fair enough? So this is the answer for the fourth question. Now let's do the fifth one. Look at the fifth one. A card drawn from a pack of 52 cards is lost. Alright? From the remaining cards of the pack, 2 cards are drawn and are found to be both diamonds. Find the probability of the lost card being a diamond. Alright, so let's take 2 events. Say E1 is that the lost card is a diamond. The lost card is a diamond. And E2 is the lost card is not a diamond. Fair enough? Now we have A. Event A. A is what? That the card is being lost. Isn't it? So, card is being lost. This is the event A, what we have. Now let's calculate P of E1. The lost card is a diamond. See, a card from a pack of 52 cards is lost. What is the probability? See, the lost card is a diamond. How many diamonds are there? 13 diamonds are there. Out of 13, one card is lost, but whereas it can be any card, right? So we can say there are 13 diamond cards out of 52 cards. So 1 by 4. Fair enough? If the lost card is not a diamond card, then there are 39 non-diamond cards. So 39 out of 52. It's 3 by 4. Correct? So P of A given E1. That is, the card is being lost and that card is diamond. So what are we looking at? The card is being lost, but how many? 2 cards are drawn at and are both found to be diamonds, correct? So now that one card is lost, out of 13 cards, out of 13 diamond cards, now we have only 12 cards, isn't it? 12 diamonds are there, out of how many? 51. So this is going to be 12 by 51 into 11 by 50. Now you might be thinking, why are we doing this? Guys, think about it. In a box or in a pack of cards, one card is lost, it's gone, and that is diamond, right? That's the first, that is even, right? When you lose the diamond card, out of 13 diamond cards, you have 12 diamond cards now, correct? And out of 52 cards, we have 51 cards. So if I remove the first one and it is found to be diamond, then probability would be 12 by 51, because now there are 12 diamond out of total of 51. You remove that. Well and good, you keep it aside. Now how many diamonds are there? 11. So you are going to have 11 out of 50, because you have already removed one. So what are you going to have now? 12 by 51 into 11 by 50. I hope this is clear. Likewise, P of A given E2 is going to be, so first we have 39 cards, correct? But out of 39, we don't have 52 anymore, we have 51, because one card is gone. So what do we get? 39 by 51 into 38 by 50. This is P of A given E2, right? Now we'll calculate. The question is P of E1 given A, right? So numerator 12 by 51, into 11 by 50, 12 by 51 into 11 by 50 plus 39 by 51 into 38 by 50. Correct? For the second part, see, P of A given E2. So P of A given E2 is what? Two cards are drawn at random and both to be diamond, correct? Now the diamonds are not losing. There are 13 diamonds itself, correct? But 13 out of 51. So you are going to have 13 by 51 into 12 by 50. Fair enough? Same logic. So let's do the math now. P of E1 given A. Numerator 12 by 51 into 11 by 50 divided by 13 by 51 into, oh, sorry. So I just took P of E2, I took P of E1 itself first, 12 by 51 into 11 by 50 plus 13 by 51 into 12 by 50. See, denominator and numerator LCM is the same, 51 by 50. As in denominator has LCM, numerator doesn't have anything. So when you multiply, like when you take LCM and cancel it out, you will get 12 into 11 by 12 into 11 plus 13 into 12. Isn't it? So the final answer is going to be 11 by 24. Because 12 you can take common, you can cancel it out. Isn't it? So the final answer is going to be 11 by 24. So this is the answer for the fifth one. Now, whatever the problems we have solved, everything is based on Bayes theorem. Okay, everything where you find what is E1, the event, and A, what is happening. And because this event has happened, what is the chance that it has occurred because of the event E1, E2, whatever. This is Bayes theorem. Alright, so in the next one, we'll look into the summary as to what exactly we learned in this particular chapter.